kung gusto mong unahin yung epicenter distance o yung arrival of P wave because you'll be using lag time, given na yung lag time. Solve tayo? Paano to? 4, 7 minus 3, 4. 5 minus 1, 4. 44. Is that 44? 1 minute and 44 seconds. Tama ba? That's 104.
Yes po.
104 seconds. So our lag time in here is 104 seconds. Hindi ako makakapagsalat dito. So, if you have 104 seconds here, madali na lang natin makukuha yung epicenter distance. Anong gagawin? Asan ba calculator?
Just multiply by 100.
Multiply by 100. Divide by
8 seconds po.
8 seconds. So, ganun lang. Ika-cancel out natin yung seconds and the remaining unit would be a kilometer, which in turn is correct because we are looking for a distance. And it's kilometers. Sige, pag may sagot na kayo, lagay na lang dito sa chat box para I would know if you are really trying to test your skills. Kasi this one is a skill-based this is skill-based na lesson, no? Kailangan marunong kayong mag-compute nito, mag-measure, mag-scale, gumawa ng triangulation, Ayan. Nag-solve ba kayo? Try ko nga din. Ayan, may sagot na. 1,300.
Akala ko malaki masyado.
Oo, ibig sabihin, nagkamali kayo ng gamit ng formula. Pag ganon.
Meter to second po, tapos kilometer to hour po. Tama po ba?
Hindi po. Dito sa formula natin, you can express your answer in kilometers agad. Kung kilometers naman yung nasa formula. Hindi nyo na kailangang i-convert into meters or centimeters. Remember that we are dealing with distances na medyo may kalayuan sa isa't isa. Naka-kilometers sila. So that's, ano kayong na-compute ko kanina? 104 seconds. Nakalimutan ko na. Times 100. That's 1,400. When you divide that by 8, you'll get, 1,300 kilometers. That's how far this hypothetical station is from the hypothetical earthquake epicenter. We'll do practice. We'll practice more of this tomorrow, no? Dapat makita natin kasi yung triangulation ngayong araw. Next, we have triangulation method. So, parang familiar yung term. May ganito sa research, pero hindi niyo pa ata inaaral. Triangulation, parang shape, no? Triangle. But you won't be seeing triangles in the process. It's triangulation method because we'll be using 3 points or a minimum of 3 seismic station data from seismic stations. Ayan. So, I hope you've watched this 3-minute video already. If not, balik kayo sa Google Classroom mamaya, nandun siya. Parehas lang yon yung dalawang attachment na yon. The other one is linked from from YouTube, no? Kasi yung mga naka-data, usually kapag naka-data ang kabundle niya, parang free YouTube 1 gig per day. The other one is an attached file nung na-download ko na siya. Okay, panoorin nyo siya. But, sunod na. Ayan. For a review, kakagawa lang natin ito kanina. How do we compute for distance of earthquake epicenter from a seismic station? The answer is, we get the lag time in seconds, and then we multiply it by 100 kilometers and divide the product by 8 seconds. And you'll get an answer in kilometers, which makes sense because you are solving for distance. Clear po ba to? Yung gagamitin nating formula? Ayan, pa-thumbs up na lang kung clear. So, dahil kailangan nating malaman kung nasaan yung earthquake epicenter, it's not enough to study only one earthquake or seismic station, no? Hindi pwedeng sa isa lang. Kasi, for example, I computed 400 nga kanina, no? 400 kilometers. Let's say I have a seismic station here, right? Dito sa bahay ko, sa Shad, may seismic station. Let's say I have a seismic station here and I recorded a lag time of 104 seconds. I computed it kanina, and then I found out that the epicenter is 1,300 kilometers away. And that away does not tell me any direction. Hindi niya sinabing north ba ng bahay ko or south ba ng bahay ko. Ang sabi niya lang away. So I'll be needing another seismic station data. Okay. Baka meron din kayong seismic station, may mga seismograph din kayo sa bahay. I'll be needing the data for those ones. Parang ganon. So in triangulation method, we have we try to find the epicenter of the earthquake. Kung saan yung location. Ito yung epicenter na nasa taas, no? And then the actual the one which is below the ground is a hypocenter or focus. Epicenter sa ibabaw and then sa ilalim hypocenter or focus. Ganito yung itsura niya kapag pinabalita sa news, no, makikita niyo yung parang may mga ring from the epicenter for us to know which areas or regions have been affected by the earthquake. Now, may interactive ako dito about triangulation ulit. Hihimayin natin to. I hope you are using a good or wider screen. But if not, I'll be posting this presentation later and you can explore the interactives yourself. Oh, sorry. Ano ba yan? Bumalik. Ayan. So I'm here I hope you're seeing this. I have here the map of North America again, and then there are 3 dots. Tama ba yung na-share ko? Ayan. And these 3 dots represent 3 different seismic stations. And these 3 different seismic stations, we have here sa gilid, we have seismogram records of a particular earthquake. Dito sa taas, makikita natin yung walk run. Sabi dito, 3 seismograph stations can tell us where an earthquake occurred. Let's touch the seismograph station on the map to see how we can use information to see how far the earthquake was from the station. Let's start with the green one. The yellow one, itong nasa taas. Mexico. TEIG. Ayan, I hope you're seeing this. The lag time is 1.5 minutes. And approximately 1.5 minutes, that's 90 seconds, no? 90 times 100 divided by 80. 8 lang pala. Divided by 8. So, approximately, ang layo niya ay 900 kilometers daw. Okay. So, kung makikita natin dyan sa tinouch natin na earthquake seismic station, nag-draw ng yellow na circles surrounding the seismic station with the radius of 900 kilometers in scale. Naka-scale to. Okay. Punta tayo dun sa Soko, sa Violet. I hope nakakasunod kayo. Ayan. 3 minutes daw yung lag time. Approximate lang yung pagkaka 3 minutes niya dyan. Maybe it's 3 minutes and ilang seconds pa. Pinakikita lang dito kung ano yung pagkakaiba ng 1.5 minutes yung lag time and 3 minutes yung lag time dito. And we have the green. Ito, siya yung may pinakamalaking radius, pinakamahabang radius, kasi siya rin yung may pinakamatagal na lag time. Remember na yung formula natin, D is equal to TD, no? The distance is directly related to lag time. Ibig sabihin, pag mas malaki yung value ng lag time or mas matagal yung appearance or pagdating ng interval ng pagdating ng P wave at S wave, mas malayo yung pinanggalingan ng earthquake. Now, since we've seen three different stations and their ranges, no? Kung makita nyo tong SPA, yung green, kung makikita natin yung linya niya, all of those points being touched by the green lines are possible locations of earthquake, as well as this one. All of the locations being touched by the yellow lines are possible earthquake locations. And also this one. But for us to know where exactly that earthquake took place, kailangan natin silang pagsama-samahin, pagsabay-sabayin. Ayan. And we found the location right at the common intersection of the three circles. Ayan. If you have questions, you can open your microphones kasi I'm not seeing you at the moment and I can't read the message box at the moment kasi nilakihan ko yung screen for the triangulation. Now, tingnan natin kung nasaan yung epicenter ng earthquake. Yan, yung may star, yung nakikita niyong star. Yan, doon ang galing yung earthquake. Okay. Tignan na naman natin ngayon kung anong nangyayari, ano yung nangyari actually nung nagkaroon ng earthquake. If we would to look at the data, yung seismic station na may pinakamabilis na recording or I mean pinakaunang nakapag-record ng P-wave ay yung yellow PEIG. Tignan natin kung anong nangyayari. Ayan, from the earthquake epicenter, we have the red one and the blue waves. Those are S waves and P waves. Ulitin natin yan para mas makita nyo kung anong nangyayari. When earthquake happens, the waves has been generated all at the same time, but the red one, which is P wave, is traveling a little faster than the blue one. Kung makikita nyo, the moment the lines, the red line and blue line, touches the station, tsaka nagkakaroon ng recording ng ganun. Yan, ulitin ko pa dahil natutuwa ako sa kanila. Yan. Kung babantayan nyo, ayan, parating na sa green and there. Pag tama niya sa green, or pag tama nila sa seismic station, nare-record na yung kanilang kanilang intensity, yung shaking of the ground brought about by that particular wave. Ayan. This is also on your presentation is sent ko mamaya. You can have this later kung gusto nyo. Ipapakita ko lang yung walk run experiment dito. So, ayan, paano nga ba yun? Yan. So, the boy represents the P wave. And then, the ate girl, she is representing S wave. She's a little late because she's walking. Si kuya mo ay tumakbo. Kaya nauna siyang nakarating sa station. Okay. Pinakikita dito yung 3 different stations. Naka-graph kung saan manggagaling yung earthquake. Ayan. Pagdating ni Kuya sa Station 3, ayun, naka-record na siya. And then, pagdating ni ate mo sa Station 3 ulit, mare-record na rin siya. Ayun. Yan. Also, yung nasa baba, hindi ko siya ma-scroll down. I don't know why. Kasi baka dahil extension lang. Kailangan ata nito ng extension. Balik tayo. Mamaya, if you want, you can explore that part more. nandito siya, naka-link naman siya. Ayan. And hindi naman, no matter how hard you root for ate girl, hindi siya mauuna kasi naglalakad siya. Is it possible to tell the earthquake epicenter location using data from a single seismic station? The answer is no, or else you'll be pinpointing several locations. Ano lang, manghuhula ka lang. Basta 500 kilometers away. Kahit saan na dyan, basta 500 kilometers away. Pakisabi sa news, ibalita 500 kilometers away from my station. Hindi pwede. No? Sa news, ang dinidiscuss nila ay, or ang binibigay nilang detail ay epicenter. So we are using triangulation method, but also, kaya nung nasabi ko kanina, there are no triangles here, only circles. Okay. Triangulation method is a common way of determining something's location using locations of other things. And those things that we are going to use in locating earthquake epicenter are the records from different seismic stations. Nakikita niyo dyan, D sub 1, D sub 2, D sub 3. Those are radius of the circles, and those radius should be equal to the computed distance, no, from the epicenter. Ayan. The point where they intersect, or kung hindi nyo masyadong na-calibrate yung map na binigay ko sa inyo doon sa yung pinost ko na map, maybe kung saan lang yung mga pinakamalalapit sila. Kung saan yung pinakamalalapit na muntik na silang magtagpo, gano'n. Pwede na yan. At least you know how, and at least you know the concept. Triangulation. Kaya kayo compass. Ayan. Pwede nyo rin ata itong gawin sa Word, parang mag-i-insert na lang ng circle. Pero mahirap atang hanapin yung center, but tignan na lang natin ko. Kanya-kanyang diskarte, no? Kasi,
Miss,
yes
question
po,
po.
sige lang.
Miss, paano po pag yung dalawang earthquake po nangyari at the same time?
Okay, pag yung dalawang earthquake nangyari at the same time, nagkakaroon dito ng ano no, ng problema. Nagkakaroon ng problema kapag yung dalawang earthquake nangyari at the same time. Kasi na-alter nila yung ano no, yung location. But the seismographs, no, in the seismic stations have ways of knowing kung ang na-receive nila ay P wave na ba or S wave na. Halimbawa, P wave, and then there's a second P wave before the first S wave and second S wave. Parang ganon. Alam din nila kung nag-overlap ba yung details. Parang ganon. But don't worry, you'll be solving hypothetical earthquake epicenters. That's a good question, no? Paano nga naman kapag nagsasabay yung dalawang earthquake from different locations? Pwede naman yun. The seismograms would still record them kasi shaking of the ground pa rin naman yun. And the seismic station still has a way of knowing which one is the P wave and which one is the S wave. I think there are difference in altitude. Okay. Ayan. So here are steps in finding here are steps. May questions ba? Hindi ko nakita kanina. Ayan. Miss, di po need na sobrang sakto yung sukat. Dun sa practice natin, no, kasi tinry ko yun i-triangulate bago ko siya ibigay sa inyo. And hindi naman sumasakto yung isang practice, hindi siya saktong-sakto, but nasa iisang state lang yung malapit yung nila, yung convergence nilang tatlo. Ganun. Ang nakalagay naman dun sa ano nyo, sa instructions, parang you have to shade the whole state, no? Kung saan nangyari yung epicenter. So, hindi siya makaka-apekto sa answer. Thank you. And also, these are steps, if you can read this. There are steps din dun sa inyong home study material and graded worksheet, yung ko. Meron ding steps dun sa SLEM na bigay ng DO. So, kung alin yung feeling nyo pinaka komportable para sa inyo. This one here also used 3 different seismic stations. Pwede rin namang dalawa, pero there are 2. Kung makikita nyo, halimbawa, let's disregard this blue. Tapos, dalawa lang yung ginamit natin. So, it could be somewhere here or somewhere here. Ayan. Pag dalawa lang yung ginamit natin. Pero kapag kumuha pa tayo ng details from the third seismic station, it could give us a better answer dito, hindi doon. Dito pala. Parang ganun. And the question, why do we need data from 3 seismic stations for us to determine a single earthquake epicenter? Parang napaka naman, no? Parang ano ba yan? Napakahirap naman. Iisa lang yung hahanapin natin, pero 3 yung kakailanganin nating data. So the reason is, yes, we need to find an earthquake epicenter. And the only thing an earthquake seismic station can do is record the arrival of P wave, S wave, determine the intensity doon sa location na yon, but they can't determine the exact location of the earthquake epicenter or where the epicenter happened. Meron ding formula in finding the depth or the depth of the focus, kung gaano ka lalim yung pinanggalingan below the ground, kasi as we all know, earthquake epicenter is just on the surface, no? But wala na siya dun sa ano natin, wala na siya dun sa sa main objective natin. We can do that, but the formula is parang mas komplikado siya. Pwede rin naman natin gawin. Okay. Ayan, and for locating volcanoes, earthquake epicenters, and major mountain belt, this is an activity, but we'll be doing this in groups. You have your groups na, no? And you have your group leaders also.
Yes
Ayan.
po.
Siguro next week natin gawin tong group activity na to. Or siguro I'll be posting this by weekend para pagtulong-tulungan nyo. You're just going to plot the volcanoes. Bibigay ko yung location, and then yung earthquake epicenters, bibigay ko rin yung location, and ipa-plot nyo lang kagaya nung ginawa natin dun sa interactive. And I think mas maganda pag pagtutulong-tulungan nyo siya. Magpa-plot lang naman. Siguro gawa tayo ng isang Google document per group, and then you add your members, and then add nyo ko. Pag nag-add nun, di ba, email address lang naman. Have you tried? Kung nag-try na kayo makipag-collaborate sa inyong mga groupmates, pwede yon. I-share nyo yung file sa kanila. And then, pwede na kayong mag-work ng magkasabay. Ayan. Yun lang naman yung gagawin natin sa group activity. Also, I'm reminding everyone that worksheet 3 has already been posted, and nagkamali ako ng labeling ng para sa activity tsaka para sa practice, but we will follow what's on your printed printed material. I-disregard natin yung nasa HSMGW, yung nakapost, kasi I'm planning to change it into the original or the correct one, the correct file, but nakapag-start na yung iba. Pag dinilit ko yung post, mawawala lahat ng ginawa nila. Kawawa naman. Questions, clarifications, violent reactions, or if you still want to go back to certain slide and ask question. Dito tayo ngayon sa slide ng triangulation. This is from iris.edu. Ayan, kung gusto nyo ulit silang makita. Anyway, mamaya pwede nyo naman silang i-explore ulit. Kung malabo dyan sa inyo kasi medyo mahina yung signal, you can do this by yourselves later. Makita nyo, kayo mismo yung magbilog-bilog dyan. Ayan. Ayan. And kayo mismo yung mag-check nitong mga details dito sa gilid. Meron pa dito sa baba, sana makita, magawa nyo siya ng paraan para makita. That's wedge method naman yung nandun. But overall, that's a graphical representation of how earthquakes, seismic waves has been recorded. Ano yan speed time, distance time interval ata. Yan. And this one and that one. Questions, clarifications, violent reactions. Ayan, this is 10 marks, no? I'll be sending the presentation on the Google Classroom now. Marks, blue. Classwork siya para mag-appear sa inyo. And tomorrow, we'll be having class, no? More on practice doon sa natin sa pagko-compute ng lag time and the other one. Sandali, babasahin ko yung nasa chat. Bali po kaya 3 station para hindi na lang isang direction. The reason why there are 3 stations is para i-recheck kung tama nga yung location, no? Para i-recheck kung totoo ngang nandoon sa location na yon. Or I mean, pag isa lang kasi, there are other possible locations. Lahat ng 500 kilometers away, pwede. Pag dalawa naman, twice silang mag-intersect, dalawa yung point of intersection nila, kaya possible na yung dalawang point of intersection na yon yung location. Pag tatlo naman, at nag-intersect sila sa isang location, just like this one, ayan, malalaman natin lang mas precise kung nasaan. Kasi, kung titignan nyo yung green at yung violet circles, they are intersecting in 2 points. 2 common points. So, kung ang pagbabasehan natin ay yung green and yung violet circles lang, you could have answered the wrong one. No? Baka mapili mo yung isa sa kanila mali But with the use of the third circle, the yellow one, na natin, dito nga, sa mas pating sa baba. Kasi it's 900 kilometers away from the yellow one And that one, yung nasa medyo taas na intersection, that's too far. Kaya, napipinpoint. Ganon din, kapag ang details mo lang ay si Violet, tsaka si yellow, pag yun lang yung details nyo, meron ding dalawang common intersection, no? And you might think na, dun sa taas, baka doon yung earthquake epicenter. Pero hindi pala. Ayan. Ganon yung reason niya. Ayan. Other questions before we end this? Kasi I believe you still have another class after this na. Hanggang Wednesday yung 3 o'clock nyo. Kind of.
Miss,
Yes po.
question po.
Sige po.
Miss, hindi po ba na-affect yung data na nakukuha ng seismograph kapag po may mga demolition po na nangyayari sa paligid po nung seismic
Okay.
station po?
Yes. Yung mga demolitions na yon are producing seismic waves. No? They found out that it's the earthquake that produced seismic waves. Pag may mga ganon, certain vibrations lang sa ground yung napoproduce. So not necessarily traveling at specific intervals. Parang ganon. Alam ng mga seismograms, kung yung na-record doon ay isang seismic wave. Actually, the seismometers or seismograms are sometimes nasa ilalim ng lupa. Sa ilalim ng lupa sila nakalagay. So they would know better if it's the shaking of the ground per se or just constructions and other stuff. Ganun. Pag constructions kasi 'di ba kapag nagkakaroon lang ng demolition diyan sa kabilang kanto, hindi naman natin nararamdaman yung shaking of the ground. Or kung ano man. Parang ganun yung
Thank you po.
Ayan. Ayan. So far, we ended with 34 participants. I hope you learned something from today's lesson. And hindi tayo dinalaw ni Sir Abel ngayon. Inantok ata siya sa lesson ko kanina. Charot. So I'll be sending the Any more questions? Still have 1 minute. If wala na kayong tanong and you'll be preparing for the next class because you still have your 2 to 3 class, no? You can now leave the call. Your attendance naman has been recorded by the attendance checker ni Google. Okay. Thank you for participating and I hope we answered your curiosity for today's lesson.
Thank you.
Thank you,
Thank
Miss.
you
Thank you po.
po.
Thank you.
Thank you po.
Thank you,
Miss,
Miss.
ano
Thank
pong
you.
next class niyo? Thank you, Miss.
Next
Po
class,
Thank you po.
boil. 10 boil.
Boil.
Yes. Bakit?
Thank you po, Miss.
Gusto niyo magpa-hi? Meron ba
Thank
kayong
you po.
may mga tinatandaan ba